Hello, I'm going to be doing my presentation for Lab 4 on oscillations. So, the background and purpose, or our general task, was to observe and track an oscillating object moving in an arc path. Newton's second law and the energy principle were some of the principles used. The programs used were Tracker, GlowScript, and Excel. So I stated the net force was equal to the gravitational force plus the spring force. Obviously, the respective gravitational and spring forces would change as the mass moved in its trajectory, but the total net force would be the same regardless. In terms of energy, I defined a closed system, which included the Earth, mass, and spring. And since I'd redefined a closed system, this means there are no surroundings, technically. So the total change in energy is equal to the total energy in kinetic, gravitational, and spring energy. And all of these energies would sum to 0. In Tracker, I used the following video and initialized the factors from the edX videos. So the initial height was 0.7 meters. And then I proceeded to track the motion of the mass. The mass was 0.402 kilograms. After tracking my data, as you can see here, I measured the time it took for 2 oscillations, which was about 3.143 seconds. And I divided by 2, so the approximate time for a single oscillation was about 1.572 seconds. To determine the spring constant, I used the equation time oscillation is equal to 2 pi times the square root of mass over the spring constant. After putting in all these numbers and solving for k, it was approximately 4.426 newtons per meter. Issued this value to determine the rest length. I set the force of gravity plus the spring force to 0, and I solved for L naught, which was approximately 0.09 meters. All these values were then put into GlowScript. My spring constant is 6.49, and my rest length is 0.09. I altered the code to reflect energy principles. Here you can see the kinetic energy is 1/2 times the mass times velocity squared. And then I did the same for gravitational, spring, and energy forces. The loop ran for 9.2 seconds, and all this code here is similar here to this as well. I just rearranged and changed some of the initializations. For my results, I outputted an energy versus time graph, where orange is the total change in energy, blue is kinetic energy, red is gravitational energy, and green is the spring potential. As you can see, the total change in energy is 0, or a flat orange line, which does support my initial claims of a closed system. I also outputted a position versus time graph, where the observed versus predicted positions were compared. They have similar amplitudes and are relatively in phase, but something about their initial position is off, so there was a discrepancy in my calculations. In conclusion, the graph or model does satisfy the energy principle. And this is true because there is no surroundings technically in my calculations. So the total change in energy should be zero, which you saw in the flat orange line on the x-axis. Also, the time of oscillation with respect to x and y was approximately the same, given that they took very similar trajectories. That's the end of my presentation. Thank you for watching.